Hey everyone, this is part 2 of Factorising Monic trinomials. In this video, we'll have a look at difference of perfect squares, or shortly known as DOPS. So over here we have a squared minus b squared, and we can factorise this as a plus b and a minus b. As if we expand this, we have a times a. We then have plus a times minus b. We'll do b times a, and we have positive b times negative b. So we end up with a squared minus ab plus ab minus b squared. So the middle two get cancelled out. So we have a squared minus b squared. So that's the proof of this difference of perfect square. So let's go through a few examples together. So we have x squared minus 16. Now we know the rule says if we have a squared minus b squared, that gives us a plus b and a minus b. So let's rewrite this in terms of a squared minus b squared. So we have x squared minus something squared. Something squared should give me 16. So that is 4 squared. So I could rewrite this as x plus 4 and x minus 4, and that's it. That's my factorised form. All right, let's go through this again. Again, I'm going to rewrite a squared minus b squared as a plus b and a minus b. My a over here, so 9a squared, and I want to rewrite that so I have the squared on the outside. Well, something squared gives me 9, well that's 3, and I have 3a squared. Again, something squared gives me 4, that's 2. And for b, I just write down b squared. So I'm going to rewrite this. So a first, so that's 3a, and then plus the b. So remember, this is the whole thing is the a, and this whole thing is the b. So 2b, and I have 3a minus 2b, and that is my factorised form. All right, again, I'm going to rewrite this in terms of a. So I'm going to square root 12, square root of 12, because if I do square root of 12 squared, now these two operations cancel one another out, so I end up with 12. If I do square root of 12y squared, that gives me 12y squared. So that gives me this. I haven't really changed anything. And I'm going to square root 1,200. Now, this section over here is my a, and this section over here is my b. I can now rewrite that as root 12y plus root 1,200, and then root 12y minus root 1,200. So remember, it's a plus b times a minus b. All right, let's have a look at this. So I'll write that again. A squared minus b squared is a plus b, a minus b. So my a over here is x, so I'm just going to write a underneath it. And my b over here is root 10 squared. That's my b. So I have x plus root 10, and I have x minus root 10. All right, let's have a look at my next example. So over here again, it's a squared minus b squared gives me a plus b and a minus b. So over here I need to find what my a is. Well, my a is x minus 1. So let's write that down. It's already in squared form. It's my a. And my b has to be square root 5 squared. Remember, square root of 5 squared just gives me 5. So I haven't changed the answer, and that's b. So I have x minus 1 plus square root of 5 and x minus 1 minus square root of 5. And that is my factorised form using difference of perfect squares.